My name is Bogdan Amidzic, and I am a visual effects supervisor in Creator Studio. I'm in VFX industry since 2006 when I entered as a student, and I was first compositing artist, then compositing supervisor, and then around year 2013, 14, because I was leading the whole projects, I started learning Houdini and getting into effects, and now there I am, like more into 3D. Today I'm going to present you some of the projects that Creator did over past 10 years, which are connected with underwater stuff. We started like our first feature film projects were about sharks, about surfers. So it's we are long in the field of water effects. Okay, so first I'm going to show you our show reel. Okay, so we started working somewhere around 2005, after 2005, and we were doing a very diverse range of projects. So back at the time, mostly commercials. And Jamie Wells and some other senior guys from my lab. And we have three teams. One is effects, one is compositing, and one is character team. And our pipeline is ever evolving. So we are always trying to invent new ways to do stuff. And as you see on these pictures, we work hard, but we also party hard. And these are some of the titles you saw in the reel. So we worked on a couple of Hollywood films, Netflix series, Apple TV series, and also at the same time we are working almost every year. We have some projects for Bollywood, and lately okay. So here you will see collection of underwater shots that we did. So I made kind of a underwater reel. So this is Shark Night, and this shot in particular was done by Igor Janic, and he used Naiad for these water effects. So Naiad is uh, was very good flip solver, and it was later integrated into Maya as Bifrost. And later Igor switched completely to Houdini. This project is called King's Daughter, and the title that we know it that we used was The Moon and the Sun. So here we did a lot of these underwater shots. For Chinese clients. Um, so we did a lot of these like underwater distraction shots, and this for us was most challenging project that we ever worked on. So we got these huge submarines as the assets from the client, and we did this. We got also these cliffs, and our job was to destroy everything. Okay. Yeah. So there is some underwater explosions. We'll talk about how these type of effects are made. And this was the last shot in that sequence. This is one very interesting project on which we collaborated with Tamshik Meetings. So it's not even VR. It's more like a projection room. So we did uh, all the visuals for this, and the output was very heavy and demanding, 18K square, and DNA strains, cities, and so on. And here it is. Now you will see how it actually looks. So this is some people enjoying it live. Yeah, so there is this underwater sequence in which we did this fishes and other animals. So, theme of today's lecture will be scene layout and some tips how to populate the scene. Also, character setup. Also, some tips there. Rendering setup, effects, and some compositing tips. Okay. So let me switch. Yeah, so regarding scene layout and populating the scene, so start with a simple like the first iteration of the scene, and here I was doing some like height field distorts, and creating some kind of crater in the middle of the scene, and like pretty fast in the process, because I wanted to do something similar as this submarine film. So I was planning to block the scene with the use of a really simple rigid body simulation. So here you see I drew these fracture lines. So don't be afraid of like manually drawing the cuts. Sometimes that's the best solution. And yeah, so I was doing some VDB fracturing, and if you are interested in that kind of stuff, I have the whole lecture about that on last year's FMX. So basically, here I was creating some like under collider, and the idea was for these big chunks to roll down the hill. Okay. And here you can see how this simulation looks, and this is from the camera view. Okay, and this is the play blast. Okay, so this is really okay for first iteration of the scene. Like you need to iterate the camera and the blocking of big elements, and then on top of that, like the next step would be to do instancing of the elements. So you see some other examples in which we use the same techniques. So this was done for 3 shots actually. Like the same collapsing simulation was used for 3 shots. And also one really good tip is to set everything into rendering as soon as possible. So to move as soon as you have blocking, like give it to the lighters so they can develop the light and the mood of the scene. Or if you are lighter, then do it. Okay. So for these assets that would be instanced, the best way to package them, I highly recommend it, is to use component builder. So in our studio, we use component builder for like every asset that is simple, like hard surface asset and like rocks, even for the trees, bushes, and I don't know, architectural elements, vehicles, and so on. So component builder is very good, and it has really good streamlined ways to work with geometry and material variants. So here you can see all the variants for these rock assets laid down. Instancing is very powerful thing, and I'm not going to dive into like details about it. Later on, I have link for the lecture that I made for instancing, but basically, if you can use it, use it. So point instancing is most efficient way to create scene complexity without too much of the memory cost. If you have animated instances, things can be more tricky. So, for example, if you have, let's say, the 200 frames floop, let's say some tree swinging, and you want to randomize, you have, for example, 10,000 instances, and you want really randomization of the time. So if you decide that each instance could pick any of these 200 frames, then you don't have instancing. Basically, all of these 200 frames have to be kept in the memory available for at any moment. So that could easily fill your RAM memory. So be aware of that. So there is another way how to handle animated stuff. Here I rigged this fish with Kine effects rig. So basically, I just rigged it to the line, and you will see here, yeah, it has some sloppy deformation. I'm not rigger, but this is how much I understand it. Yeah, so it has 4 joints. So basically, what you can do with this rig, you can import it directly into Stage. So if you go into Stage and use sub character input, what you will see is that this is not regular geometry. This is actually the type of this geometry is called scalar root, and you can see it in metadata. Yeah, so basically what this type of primitive allows is, yeah, so you will see now. So basically we have animation. This is primitive which contains bone animation data. We have our geometry, which is like regular, like any other geometry in Solaris, but this is geometry only in the rest pose. And then we have skeleton, which is like rest pose skeleton. So basically, in memory, what is kept is rest pose geometry, rest pose skeleton, and animation data for the bones. and the weights, of course, for these bones. So basically, this works in the same way as FBX works in game engines. Okay, so in the context of your underwater stuff, where USD skeletons could be really useful is for corals, for seaweed, and for the fish flocks and this kind of stuff. Okay. Yeah, so let's dive a bit into like organizational stuff for the characters. So here, this node in stage, which we call load shot assets, loads all the necessary assets for our scene, and they are loaded in the rest pose. And basically, what happens? Oh, okay. Yeah, some glitch. Okay, so basically, yeah, let me go back a bit. So we have this load shot assets, which loads all the necessary assets. And then we have another node which loads animations. And when we load it, you see that now we have cameras added, and we have actually animation data for the characters loaded. So in the scene graph layers, you can see like what are the sublayers of the animation USD and what are sublayers or references in low shot assets. And really important and crucial thing is the fact that our animation USD has exactly the same hierarchy as the assets as they are loaded. So basically, I invested a lot of time to create a decent exporter from Maya. So we don't get any of these like nasty namespaces, underscores, and these kind of things. And basically, when animators export stuff, we always know what are we getting. Like it is in the proper place in the hierarchy, named in the way we expect. Okay, so that's the thing that like I could advise to invest time in streamlining pipeline between animation and light and effects. Okay, so yeah, I was speaking about these USD skeletons. So this this is from this American Museum of Natural History project. So we did fish flocks for this project, and here you can see how that is set up. So we have two emitters, one for dolphins and one for fishes, and basically there is a node called pop flock in DOPS, which allows you to do this kind of behavior. So it's really not complicated, and there is also node steer avoid, which basically tells our fishes to avoid particles, red particles, which are dolphins. Okay. So the next step for us was to create from these particles to generate lines, and these lines, you can see them here. So these are just trails from the particles, and we just resample them a bit, smooth it, yeah. Okay, so then the next step was yeah, I'm just trying to find it. Okay, so the next step here was to take individual fish. Where are you? Okay, yeah, so the thing here was to create sine wave animation on each of these lines, and yeah, to decide what is up, because all of these fishes have to be oriented, their fin should be pointing upward, so that was also important in here. And then next thing was to yeah, to basically take the fish and path deform it based on these lines. Okay, and then we did it in for loop. So this was sped up like 100 times. So it took around 4 or 5 minutes to cook it. And we were back at the time, we were caching all of these fish into one. We were caching them into BGO files, and these files were enormous, like 1 terabyte. We had a lot of frames, but this was a nightmare in terms of storage. Okay. So I was thinking 5 years later, like, is there a better way to do it? So I created a simpler scene. So this would be our ship fish flock. Okay, and yeah, we do the same thing, trail, and here I was confused about something, but it's fine. Yeah, I was getting straight lines, but I think I solved it later. Okay, yeah, they are not steering so harshly, so it's not so obvious. Okay, so we have our fish geometry, which has screen weights, and one really important thing is to create agent, like crowd agent, out of the fish skeleton. So this is a node for creating agent, and then with agent layer to add the geometry to that crowd agent, and then we are iterating through each one of these lines representing our fishes. And basically, what is the idea? The idea is to deform skeleton based on these lines. And I first tried to do it with point deform, but that doesn't work. So the thing that you have to do for skeleton is you need to use rigvop, and in rigvop first input is your skeleton in root pose, and second input is your curve, and there is this node solve curve, which basically it not only deforms but also modifies all the other attributes, these like transform matrices. and this is the result you get. So there is no the agent pose from rig, which basically deforms your agent into desired poses. And now, if I add mountain, you see that they are also bending. So that works. Okay. So then in Solaris, there is only one node that you need to add, which is called subcrowd import, and it will not show hierarchy, but now it shows. Okay, so you see that each one of these, each fish has its own group. Yeah, I was just modifying the name, the path attributes. So I wanted nicer names. So this is nasty. Okay, so yeah, so here I'm giving it nicer path. Okay, and now our hierarchy should be refreshed. Yeah, so here it is. So basically, what we have now is we have two things. One is character group with all individual fishes, and we have one group which stores agent definition. Basically, this agent definition is like prototype in instancer, and each fish is actually referencing geometry from that agent definition. It's referencing root pose from that definition, and only thing that's different is this animation primitive. So each agent gets animation primitive, which is different with different data, and it only contains these 4 joints for each one of these agents. And great thing about this is basically when you cache this, you are not caching any point geometry data. You are just caching your skeletal data. And this is like compared to that 1 terabyte that we had for this whole school of fish. This is very lightweight. It's like a couple of hundreds of megabytes. Okay, and it works decently fast in the scene. Okay. Yeah, let me play this. So some more tips for character effects is in order for your cloth and effects, hair effects to look slower, use damping, be free to decrease gravity, decrease time scale, like whatever works. Don't be the slave of trying to have exact gravity and then struggling to have your hair floating. So these are tools, and we should use them to get artistic results. Okay, rendering stuff. Okay, so previously, traditionally, we were using Arnold and Mantra heavily on our projects, and even then, conversion between shaders between Arnold and Mantra, that was very painful, and I don't know how many scripts I wrote for this kind of stuff. So currently we are using more Karma and Karma XPU, and currently we are using more Karma and Karma XPU, and Karma CPU can produce better results for volumes, but Karma XPU is very fast. So, like, if you can use it, use it. And one really important tip is do not render everything in single image. Like this is like if you're serious about this job, like, don't do it. Okay. Yeah. So one of the first things is how to handle in these like underwater scenes, how to handle like fog. So the simplest thing is to use Z depth for your fogs. And even nowadays, like we use it, like this is totally legitimate way of working. So basically, you take your Z depth, you grade it, and you just merge it over your scene. Okay. Yeah, so something like that. If you have alpha involved, yeah, so this is without, this is with. Okay, so like pretty fast you can get some decent results. But sometimes there will be some artifacts in the edges, especially if you have some smaller details in the edges, like grass or some like hair or anything of that type. So then, like naturally, you have to blur a bit of the edges. Yeah. So basically, oftentimes what we do is we render the depth in double resolution. Yeah, so here you see, for example, for this kind of stuff, the depth is really not sufficient quality. Also for volumes, it doesn't work at all, and this is like this is not solvable with the depth. Okay, so let me see if I have. Yeah, so basically what is solution, either to render in double resolution or to render in DPXR. Okay, and also what you can't have in this like z depth fog is volume rays and like any kind of like a 3D type effects. So like nowadays, what we use for fog is we use on that previous project on submarines, we used Karma Fogbox, and Karma Fogbox is pretty cheap because it's uniform volume, so it has some like optimization considering the fact it's like single uniform value. Okay. So here I was adding some extra lights just to see how does they work in the fog. And yeah, so on these lights you have some control for focusing, and also really neat thing in these like light settings is this spread. Okay, and also we always use these light tags. So basically you can get light group for each light that you decide to assign light groups. So here I was assigning separate light groups for sky, sun, and for my area light. Okay. Yeah, and here, like in some cases, we were rendering these fogs with multiple bounces. Of course, it's more expensive, but you get some like color bleeding effects that are really nice. And we always render this fog as a separate layer. So then you can turn off some like expensive stuff. Like if you have some like expensive shaders, you can replace them with simpler shaders on like other objects. Okay. And one note on DPXR. If you render your fogs or volumes with DPXR, that can be very expensive. Like you can easily get EXR files that are like 100 times bigger than regular EXRs. So consider if that is really what you want. And the other thing is usually you don't need to render all the passes in DPXR. So usually it's sufficient to render beauty in DPXR. And also there is this option, DCM of size. We always set it on monochrome. Files are less, like almost 3 times less in size. And also this DCM bias is basically precision of your DPXR. So in some cases you can increase this value and files will be less big, will be smaller. Okay. So this is one thing that I tried on that project. I was wondering because like with DPXR, what you can do is you can visualize it. Okay, let me just play. Come on, play. Okay. With DPXR, you can do visualization in Nuke of what's up with this file. Okay, let me play it. Okay. Yeah, so with DPXR, in Nuke, you can load it with deep read. And if you do deep to points, and I will just hook any camera, what you will see is basically all of your deep samples arranged in 3D space. So there is a way to do that in Houdini as well. So basically, there is command in Vex with which you can read deep data. It's called DCM pixel, and basically it returns array of all of the samples for given pixel. And my idea was to rasterize that, to basically turn it into volume, and you will see how much. So it's not like the quality is not so great, but it is actually the same thing. Yeah, but you see how much faster it renders. So basically, this could be like maybe somebody could work on this idea. Like if you render it from multiple angles, maybe you can get better quality and like with more samples and resolution. And we were using this also on some like outdoor scenes to have basically to have sky dome, which is like to have fog volume which is colored in the same way as HDR, and this was really useful and it was rendering very fast. Okay. Okay, so for the caustics, in Karma, there is option in Karma render settings. There is option to turn on caustics, and you can see how slow it is. This video is sped up, but still it takes ages for ray tracer to converge. So this is very like it's not practical to work in this way. So the way you can do caustics, yeah, and here if you turn fog, it's even worse. So the better way to do it is to basically add additional light, and on that light you can add light filter, and this light filter is called gobo, and it takes image input, and yeah, we can see there is like light filters relationship on light primitive, and yeah, so this is the spotlight. And the way I created this caustic pattern is with whirly noise in COPS, and yeah, using some fractal noise to distort it a bit. Okay, yeah, so there is like a ton of ways to do it, and yeah, we used this kind of technique on these mermaid films. Okay, for the lighting, one useful tip is to use if you're in like deeper water, to use HDR that originated from deep water, or to create some ramps which would like diminish all like details and features in the lower part of HDR. Also, specular is diminished in the water, and you can reduce it or disable it on the lights, or you can edit all the shaders in the scene at once with edit material properties node. And basically, with these like stars, you can target several materials at once. Okay, yeah, so the next thing would be volume rays. So they can be made in 2D with volume rays node in Nuke, of course, and in rendering they can be expensive. So there are even ways to make them in subs. So you can like scatter some points and create some lines and rasterize that. And what we like to do for these rays is basically the same light that we did for acoustics. We can copy that light, basically duplicate it in Solaris with duplicate node, and then with light edit node we can say that this new light will affect only volumes. Okay, and then the idea is for that light to have separate gogo filter, which would be, let's say, the same caustic pattern but with more contrast. Okay, yeah, so here I was trying to apply gogo to both lights. And yeah, so now that we have it as a separate light, basically we can we can decide what would be the intensity of that volume race. Yeah, so here I was just rearranging these light filters, and there is a magic button to do it. Yeah, so one light, the other light. Okay, so you see that each light has its corresponding gogo, and now I can easily control them separately. Okay, so in COPS I have like another version of this caustic pattern, which is more contrasty, something like that. Okay, so this is like a sharp gogo, and then yeah, I apply it to that volume light, and you see like how I get these kind of like sharp volume rays. And the great thing is if you give these lights separate light path names, you can control them in compositing separately. So this is the clip about that. Yeah, so like these traditional passes like specular diffuse reflections are useful, but more useful is to have your lights as a separated passes. So here you can see how much control that gives you. And there is also a way to use both of these ways of compositing. So basically you can tweak individual shader elements like diffuse, reflections, and specular, and light groups at the same time. But I'm not going to dive deeper into that. Okay. Okay, and now we go into effects stuff. Okay. So to get really good like feel of the water it is very important to feel tiny particles in the water, and the way to do it is of course to generate like hundreds of millions of particles, like if your scene is big, and that can be very costly. So the idea was, can we just generate these particles where camera is, and let's say 20 meters from the camera. So basically, you can create a box and transform it to represent camera frustum. And yeah, so here I'm just cutting that box with bottom and the water, and this points from volume node. What it does, it generates points, but if you look really carefully, these points are stable, so they are not regenerating. Their positions are stable. So basically, what we can do with that, we can add, of course, a bit of animation to them, and this is enough, like curl noise. And yeah, here we can fade them to the end of this frustum and separate them into smaller and bigger particles. And then so here is how it looks. And for these bigger ones, we can attach some cards to them. Okay. And since they're packed primitives, they will be created as instancer in Solaris. And yeah, we can basically read ID of each one of these particles and attach different images, this kind of like grid images to each one of these cards. Okay, and for the small particles, they will be rendered as the small particles. So, yeah, so these are these like bigger particles. Okay, and these are these smaller particles. And if you render them as deep, you can use deep crop to get rid of these ones that are closer to the camera, and with the other ones will blur it dramatically. And yeah, this is how it looks, and it really gives you like the sense that you're in the water. Yeah, there is one closer to the camera at the end. Okay. Okay, so next topic would be bubbles, and yeah, so like the most sane way is to use pyro with the temperature and advect a bunch of particles. So we use it a lot in this kind of shots. Okay. And another way is to use white water solver. I'm not going to show that here, but basically, if you emit any white water particles under the surface, they will rise to the top. And here is like simple setup in which I want to show you. Like, okay, we do some like pyro with the temperature and it's rising, it has some vortex confinement, and then we have our particles and everything is moving too much. So basically we can try different styles of advection. So to update velocity, this is how that looks, and there is also advection method in which positions are affected. And yeah, like usually what I do is I try each one of them and see what works the best. Also, it could be useful to randomize mass, for example, for particles, and to uncheck ignore mass. And now for the meshing, basically we convert these particles into VDB and do some like random scale on them. Okay, and then yeah. And then what we do is like the old die. Yeah, so what we do is basically we do reshape and smooth, and in that way we get these like blobs of water. Yeah, so this is good, and we can play with reshape and smooth. And other particles, so we want all the other particles to be rendered as small spheres. So basically, how we can do that, we can detect which ones of these small particles are inside of these blobs with volume sample, and basically remove them from inside. And when we combine these two, this is what we get. And of course we transfer velocity, and yeah, so what happens, yeah, for these small particles, what we want to do is to reduce a p-scale on them, and this is the result. Okay, so we can apply some water reshader to this and get it into rendering. Of course, cleaning up some attributes, unnecessary attributes, that's always smart thing to do. Yeah, so this would be the final result of that. Okay. Okay, and we did, for this project, we did a lot of this like underwater lava. Back at the time, npm, I don't think it was released then. But I was really familiar with Flip, and these are some tests that I did at the beginning of the project. So basically, there is a way in Flip to have temperature and viscosity and have relation between these two things. So basically, the idea is for your fluid to be more viscous if it is cold, and to be less viscous, like more fluidy, if it is very hot. Okay, so let's see how that setup is made. So we have some geometry and we have some sphere from which we want to emit temperature. So there are a couple of nodes which are important here. So we have a volume source for the emitting of our particles. We have gas temperature update. This is the node which controls relation between temperature and viscosity. And here the thing that's disconnected is emission of the temperature. And yeah, so I'll just turn that off. And basically we have minimum and maximum viscosity, and with this pop wrangle I'm introducing some temperature onto the particles. And here you see, like, as I introduce temperature, yeah, there are some things that you need to check, like enable viscosity, and on flip object add these two attributes. And basically for the gravity, we want gravity to affect only stuff that is hot. So this is the result. I'll give you this scene, so like anyone who wants to play with this can try it. And yeah, so this was the like basic thing how we set up these lava pools. Okay, yeah, and here I'm playing with different parameters. Yeah, so if you enable diffusion, your temperature will like infect nearby particles, and you have controls for cooling, and you see how this like lower part is cooling off now. Okay. Yeah, so different kind of results. Okay, that is that one. Okay, then next thing is divergence. So what is divergence? So we want to have some pops in our lava. So in this case, with our pig head, I want the eye of the pig head to explode. Okay, and basically I just added a sphere for that. And in the same way as I introduced temperature in the system, I'll introduce something called divergence. So divergence, what it tells to our solver, it tells to the solver to expand velocities where divergence is positive, or suck in velocities if divergence is negative value. And divergence works both in flip and in pyro. So basically, yeah, I'll just repeat this. Okay, so you see how it works. Yeah, so we were using that to get these like pops of lava, like, just scattering some points, and it would pop here and there. Okay, that's divergence. And yeah, this is one of the recent projects that we are doing, and we are using npm instead of flip to do lava things. And this is also one project that we recently did in which we used npm. So basically, if you have a decent GPU, it's really flying. Like it uses power of that GPU, and typically you would do around 10 or 20 million particles, and then you would replicate them into way more particles. And on this like sand project, we did exactly that. Yep. Okay. Okay, so next topic would be underwater gases, like plumes and underwater like mines exploding and shrinking. So this was one of the shots that we did for that submarines project. So you see how these explosions, when they explode, they shrink really fast afterward, and they even emit some light. And these are some work in progress versions for this shot. Okay. Yeah. So question is how this is done. Okay, this is repeating. Okay, let me play the next one. Okay, so how does this work? So this is like a typical pyro setup in which we emit density and nothing happens. Okay, so if we add some velocity, so we want this dome to expand. So what's happening with our velocity? It's there. Yeah. I'll just adjust keyframes. Yeah, that's it. Okay. Okay, so yeah, so this is with velocity, and it doesn't look good, like it doesn't have enough power. If we emit temperature, everything will rise up. And with divergence, if you remember in flip, so basically if we emit positive divergence, things will expand. If we emit negative divergence, things will shrink. So basically, let's try to emit positive divergence. Okay, and this is immediate result. So our half dome expands way more immediately. Okay, so this could be very useful thing for us. So basically, we can add a little bit of temperature as well. Why not? Yeah, here I was just adding some multiplier for temperature. Okay, yeah. Interesting. So if we add a bit of disturbance, yeah. Nice. Okay, so the next step in water would be so the next idea would be to control this divergence in runtime. So not emit it once, but basically we want somehow to dynamically emit divergence. In this case, negative divergence. So what is the idea? The idea is to take density field of our pyro and to take density field of our pyro and to shrink it, to convert it to fog, and then if we can, okay, well, let's see. Okay, yeah, first thing that we need to do is we need to copy our density field into one field that's called, let's say, div temp. Okay, so this is just one empty field now, but if we say it equals to density, we'll see now that our pyro is outputting another field which is totally equal to our density. So basically it's the same. So next thing would be to apply all of these SOP things inside a node that's called SOP solver. So basically this node allows you to do SOP operation on each time step of your simulation. And here what we are doing is eroding and shrinking our div temp field. Okay, and yeah, so the last step would be to basically to say, okay, this div temp will go into divergence, and okay, yeah, I have to go out, and immediately we see that we have negative divergence applied. So this is even more. And what happens is if you apply too much negative divergence, you will lose a lot of density and temperature. So here I was trying to find optimal numbers. So basically, as our fluid as our smoke is getting sucked in, it would emit a lot of new density and temperature. Okay, so yeah, this might be interesting. So it needs a lot of tweaking, but at some point, like, you figure it out. Okay, yeah. So that's That is that one. Okay, to get these underwater explosions to look decent, what we found out is that you need to render your pyro as well as mesh that's surrounding your pyro effect. And also what we used, we didn't use water index of refraction, but inverse of that index. So we got this kind of look then. Because we are transitioning from water to the air, not the other way around. I don't know. It made sense back then. And yeah, you can say to volumes only to be rendered in refraction, so not to cross this, not to cross beyond this mesh. Okay. Okay. So for rigid bodies, for distractions actually, what I tend to use is basically to use rigid body simulations for like primary distraction. And here you can see some of my simulations. And basically, you can combine rigid body simulations and MPM or grain simulations to basically like big events with rigid body sims, and to do like secondary fracturing with MPM or grain simulations. Okay, and here, for example, in these submarines, we had a lot of instance stuff on top of them, also on the ground. So all of these instances have to follow like what is happening in RBD. So that was a tricky thing, to figure out, basically to sometimes to point deform actually instances to your rigid body pieces. Okay, also for this shot we did like really interesting bending of these metal plates, which is not simulation. It is more like post effect on top of your simulation. And these are some additional distraction elements that we did. Yeah, so this was the heaviest shot in terms of metal bending and distraction. And this was nice as well. And these are some tests of MPM ground collapse, but we didn't use it on that project. Yeah, so some of the like core parts are meshed and other stuff are okay. So regarding compositing, really good tips is to use your depth to lose color information more like deep you go. Also, the focus based on depth, it should be more like a soften, not like the focus. Also, we add slight glow based on depth and luminance, and yeah, underwater stuff always has a lot of chromatic aberrations. So, like more like more dirt, more like damage, more blurriness would just help you to get more realistic results. So here you can see all of these principles applied. So there was a lot of softening and aberration and distortions that we had to add to make these mermaids look believable. Also, we did a lot of effects on them, like speculars, picking different colors, like rainbow type of thing. Yeah. And yeah, here we did also some like underwater cities for this film. So this is the setup for compositing, which takes strengths of both principles of merging the image from passes. So on the left we have light groups. So this is each light has its own light group, each light tag. And here on the right, we have shading components like diffuse, specular, direct diffuse, indirect diffuse, and direct specular, indirect specular, and reflections. So, yeah, so basically, there is a way in which we divide that shading components and beauty, and then we multiply it by light group results. So basically, in that way, you could tweak, for example, a direct specular, and at the same time, you can tweak contribution of the lights. Yeah, I switched sides. Yeah, so you see, and at the same time, on the left side, come on. Yeah, this is an indirect diffuse, and here we tweak, let's say, this one. Okay, and when we see the results, so nothing breaks apart. So both of these principles can be used at the same time. Also, in next couple of days, I'll send you all of these scenes that I was showing examples, so you can use them and, I don't know, like make something out of them. Yeah, so all of the examples that I was showing are in this scene. Okay, so a lot of stuff that I only touched here are covered in many of my lectures, like like building procedural ancient cities. There is a lot of things about instancing there. Also, this last thing to automated instancing. Also, Tokyo Hive. So, like anything you want to know regarding of like Solaris instancing. There is a lot of stuff that I already told. Also, distractions in Solaris that was last year on FMX. Okay, questions.
Awesome. I see that there's a question coming through right now. It's from Hugo, and they say, "Hey, I've really enjoyed the lecture. Here are my questions. I'll take them one by one because there's a few. You glossed over bending metal as a post effect instead of a simulation. How did you do this? Using a deform on soft constraints, or is it completely loose from the simulation?"
We have like primary simulation, which is soft constraints. It's rigid body and soft constraints. But to get these like smaller bends, we basically we were measuring where the splits were happening, and then based on directions from the split, we were basically we were adding something like bend deforms per piece per this like metallic sheet. So each sheet was going in for loop, and it was figuring out, okay, the crack is there, so I should probably bend 90 degrees from the crack. And yeah, so it's there was a good presentation from the guy. His nickname is Animatrix, and he has really good courses, Pragmatic Wax. So he also explained a lot of these kind of principles, like when you want to create this like peeling of the sheets. But his solution is way more optimized than mine.
Is this something that they can find on YouTube?
Yeah, there was his presentation was part of a Tokyo Hive in October of 2025. It's on scientific site, but also like just type an Animatrix Houdini, you will find him, or Pragmatic Wax. Like he has really good low level Houdini master classes.
Perfect. The next question, again from Hugo, he asks, for distortions, did you render separate layers that helped, or did you do everything in comp? He wants you to know that he's used red and green particles for heat distortion in the past, but he's curious if this is similar.
Yeah, that's the way to do it. Right now, on some other projects, we are doing it in the same way.
Amazing. And then we have two more. With the explosions, did you have underwater shockwaves? If so, how did you build them?
Uh, Here on this project, no, but I would do it partially with distortion, like create like expanding circles around the explosion, which would have maybe you can use like velocity vectors and render them like straight to custom AOV, and use that for I distort in nuke. Uh, that in combination with some like smaller particles following that, I think it would do.
And lastly, from Hugo, how do you determine what should be a separate render pass? I think a really good question.
Uh, yeah, that's something that we very why I said it's very important. Like when you have anything, kick it off so if you're in the team, like don't wait for your stuff. Let's say you're doing I don't know, animation effects, and basically you want your stuff to be perfect in order for somebody to pick and light it. We don't do it that way. Like we have this like principle, like no matter how much it sucks, let's see it in render, so people doing rendering and light, they could early on figure out like what would be the best division of renders. So here in this case, we had to divide for these submarines. One reason was also because things were heavy, so it was more optimized that way to render, let's say, background environment, foreground environment, submarines separately, effects separately. So that's something like if you have comp in the team, that's the thing between, let's say, effects people, comp and light, to let's say make agreement. And we do that on our shows. We do that for this like milestone shots, for key shots, and then we can package this like template of karma ROPs and overrides, and like we package that into recipe, and we can reuse that on many shots, this kind of like setup for different passes.
Thank you so much for that detailed answer. He's also saying that he's looking forward to tinkering with the scenes, and I think my audio cut off just right when I was asking about this. So the best way that they can reach you to ask for the scenes is through LinkedIn?
Yeah.
Awesome. So if
I'll,
anyone's... Sorry, go
I'll
ahead.
just I'll just clean these scenes a bit and post it. And for video, I can also post it like because there were some technical issues, and on my side, the resolution wasn't perfect. So maybe like if somebody's curious about these like vex snippets, maybe I can give you higher resolution video.
Perfect. We also have a question coming in from Mara. How did you animate the direction of the particles?
Uh, can you be more specific? Which particles?
I will give her a chance to respond, and in the meantime, I'll move on to a question from Simon while Mara clarifies. I really like the shallow underwater ocean shot. Did you use the default procedural ocean, or did you build the surface from scratch?
No, that was like grid with the mountains. So I didn't want to invest any time into that. But we usually use Ocean Spectrum for this kind of stuff.
All right, because they're saying they had quite some troubles with the standard one. Is this something that you've experienced yourself?
With the standard one. So there is like a new one that's called Ocean Procedural. So there are some tiny things that you need to be careful with it. Igor and me, for some projects, we prefer to use like older way of doing stuff, like older shaders, but they don't work in Karma XPU. So that's uh, that's the downside. Uh, like if you have any problems with ocean procedurals, just text me and like we can get into more details about that.
Awesome. Thank you so much for being open. I don't see a response from Mara coming in. Let's give her a few more minutes.
Yeah, for if she referred to particles for the fish, basically when you do trail, so that was how we got these like lines for the fish. Basically, we use trail, so we spawn particles back in time in like fractions of the frames, So you can connect all the particles with the same ID into the lines and use these lines for the fish, and just the order of these points will be correct. So the direction will be right, if that was the question.
I'll have to assume so. And
But there
it,
is in example scene there is also example with the fish. So all of these examples that I was showing is in that example scene that I'm going to provide you with.
yeah, so give Bogdan some time to gather the assets, and then he will be able to share them with you. This is great. Thank you so much for joining. This was a really detailed breakdown of all different types of underwater scenes that I think could be super beneficial. People can refer back to them if they're struggling during a project. You're
Yeah.
coming from a lot of years of experience, so I think it's very helpful for students joining.
Yeah, and for me it was like some of these things like it's really good to have opportunity to let's say revisit some of the stuff that we were doing in hard way, and now like discovering there are way more like better and optimized ways to do stuff.
It was a learning opportunity for you as well, then.
Yeah, yes.
Happy to hear. Any final words, anything to share with the students watching?
Um, uh, Feel free to contact me. Like I'm lecturer myself, and I like to help other people advance.
That's wonderful. Uh, Thank you so much, Bogdan, for joining the Avenue Masterclass. It was a pleasure to have you. Thank you to all of our viewers. This was probably the biggest turnout that we've had, so I'm really hopeful that everybody got what they could after watching this presentation. And you can always rewatch this. Just make sure to follow our LinkedIn Avenue CoVE. The video is available right after the live stream ends. Yeah, follow us and keep a lookout for the next master class coming in the next month. It was a pleasure to have you here today, and I wish you a wonderful rest of your weekend. Bye, everyone.